Assalamualaikum and hi everyone. We are from class 6. We present session 260 video assignment of gas chromatography and high performance liquid chromatography. Firstly, I am Nur Izzat Azwani Binti Sharifuddin will present introduction of gas chromatography. The objective is to analyze the vanillin in white chocolate by gas chromatography. Vanillin is organic compound with molecular formula of C8H8O3. Vanillin is phenylaldehyde with functional group of hydroxyl, aldehyde and ether. Furthermore, it is also a primary component of vanilla bean. Synthetic vanillin is used as a flavoring agent in beverage and food due to their vanilla aroma and strong milky flavor. Gas chromatography is an analytical technique for distinguish the volatilities of components based on the boiling point differences. By vaporizing a sample in the column, gas chromatography separates component in itself based on partitioning behavior between the mobile and stationary phase. Mobile phase, also known as carrier gas, is typically helium or nitrogen. Meanwhile, the stationary phase is boiling liquid absorbed on solid. Gas chromatography is important because of its simplicity, high sensitivity, and ability to separate mixture. Furthermore, the instrument used in this video is gas chromatography mass spectrometry, which is a device that combines capabilities of gas chromatography and mass spectrometry. GCMS can identify various organic chemicals found in organic matter, separate complex mixture, recognize unknown base, and also detect level of contamination. Principle of gas chromatography. At the injector, a sample is injected and vaporized into the chromatography column. The sample is then carried through the column by an inert gaseous mobile phase flow. As the sample travels through the column, it is split and analyzed electronically by a detector where the results are recorded on a chart, in which the component can be quantitatively and qualitatively defined. The instruments for gas chromatography technique are carrier gas, injector, column, detector, and display system. Meanwhile, the principle of gas chromatography mass spectrometry also same as the gas chromatography. However, when the sample passes through the column, the chemical separated by interaction with column coating and carrier gas. Then, the columnar section travel via heated transfer line and finish at ion source entrance, where the substance eluting from the column and transformed to ions. The components are identified based on their mass to charge ratio. Next, methodology. The first step is sample preparation. In 20 ml HSP bottle, we powder about 1 gram and 2 gram of NaCl were mixed with 5 ml deionized water. Then, the solution was mixed for 3 minutes with MS3 basic turbo mixer. After that, for standard preparation, 0.05 gram of standard substance was dissolved in isotonitrate to form a final 100 ml solution. Then, 10 ml standard stock solution was diluted with isotonitrate to make 100 ml. The standard intermediate mixer solution will progressively diluted with a blank milk powder matrix. After measuring under working condition, standard curve will draw with peak area versus analyte concentration. Lastly, for GCMS analysis, Figure 1 shows the detector applied to quantify the contents of vanillin and ethylene vanillin.
Assalamualaikum and hi, my name is Husnanajia and I will continue on the methodology. For analysis of the result, a mass spectrometer will detect the compound as the separated compound pass through the column, and then the chromatogram will identify the retention times, and then the mass spectrometer will use the peak to determine what molecule exists in the compound analyzed. And figure 2 shows the schematic diagram of the gas chromatography. Next, for the analysis part, here are the sample analysis results for qualitative analysis in the figure 3. According to the table about the detection of concentration of vanillin and ethyl vanillin in milk powder, the data shows that for vanillin, the highest detected is 16 and follow on formula, while the lowest is 12 detected at infant milk powder. For ethyl vanillin, the lowest detected is 10 at infant milk powder, while the highest is 16 detected in follow on formula. After that, from the chromatogram, it can be shown that there is presence of vanillin with retention time of 9.647 minutes, and the first peak is vanillin and it diluted first due to the compound's boiling point, followed by the second peak of ethyl vanillin. It has higher boiling point of 295.1 Celsius and cause the compound to retain at stationary phase, and compound that has lower boiling point like vanillin, which is 285 Celsius, will elute first. Then, for the discussion part, firstly, the selection of extraction fiber type. According to the law of similar mutual solubility, non-polar fiber coating had higher extraction efficiency for non-polar volatile compounds, while polar fiber coating had higher extraction efficiency for polar compounds. Then the study was conducted under the following parameters, which are the incubation time, oscillator rotation rate, extraction temperature, extraction time, desorption temperature, and also desorption time. So, however, the chromatogram obtained relatively distinctly, which was mainly because the type of extraction fiber had strong absorptivity to the tested components. The peak area of the analyte increased as the incubation time increased. 40 minutes was chosen as the optimal incubation time. 500 RPM was chosen as the oscillation rotation rate. This is because the increase of the rotation rate not only accelerated the evaporation of volatile components into gas phase, but also enhanced the airflow of the air space, which increased extraction efficiency. So the result indicated that the peak areas of vanillin and ethyl vanillin reached maximum value at 80 Celsius. Vapor liquid equilibrium was achieved at 40 minutes. 260 Celsius was chosen as the optimal desorption temperature. 5 minutes was chosen as the desorption time, and lastly, for the precision and also recovery, the spike recovery of vanillin in sample ranged from 90 to 99%, and that of ethyl vanillin in sample range from 97.5 to 100%.
In conclusion, this chromatography method greatly eliminates the interference of complicated matrix in milk powder by simple pretreatment. The spike recovery of the sample ranged from 90% to 100%, and RSD ranged from 1.9 to 5.1%, while for the LOD range was 0.1 and 0.05 mg per kilogram. Vanillin and ethyl vanillin perform a good linearity within the range 0.1 to 2 mg per kilogram and 0.05 to 2 mg per kilogram, and the calibration of coefficient were 0.9992 and 0.9991 respectively. This method possesses advantages in terms of high analytical efficiency, wide linear range, good accuracy, and good precision. Therefore, this validated method is suitable for rapid determination of vanillin and ethyl vanillin content in milk powder.
Hi and Assalamualaikum. My name is Nur Syafiqadana binti Syafi'i, and I will explain the introduction of high-performance liquid chromatography experiment. The objective of this experiment is to determine the vanillin in vanilla essential oil by high-performance liquid chromatography. The principle begins with the injecting the solute, which is analyte, onto the top of the column. Separation occurs as the analyte and mobile phase are pumped through the column. Each component elutes from the column as peak on the recorder. The response of detector to each component is displayed and known as chromatogram. Next, the concept. The function of HPLC is to separate molecules under the high pressure and resolution column, and it also uses automated computerized instrumentation for extremely effective separation of molecules. High resolution column create more interaction site and greater resolving separation power. High pressure increase the speed of the separation to the high resolution column matrix. High performance liquid chromatography instrumentation contain mobile phase reservoir, pump, injector, column, analytical and guard column, detector, and data system. Next, the methodology of quantitative analysis. The system suitability test was performed by injecting a standard solution of vanillin 60 microgram per ml as 6 times in a predetermined HPLC system. The linearity test was carried out by injecting different concentrations of the soluble in ethanol vanillin standard. 5 ml of vanilla essential oil sample was inserted in a separating funnel. Each of the funnel was extracted 4 times with 25 ml of chloroform addition. The bottom layer is taken. Then, the extract, which is chloroform layer, is evaporated over the water bath until the chloroform evaporates entirely. The solvent-free vanillin extract is dissolved with ethanol up to 5 ml. The sample and standard solution were injected into the HPLC system. The reverse phase system was used with methanol as the mobile phase. The vanillin was calculated with the linear regression equation from the standard calibration curve. The methodology of qualitative analysis. The Jergen-Loff test sample was separated into 3 groups, which is A, B, and C. The sample was dissolved in 10 ml of chloroform in a total volume of 1 ml. 4 drops of ammonium hydroxide were filtered and the filtrate was inserted into a closed reaction tube. The chloroform extract in the test tube was shaken with 6 ml of 2 moles sulfuric acid, and the acid layer was separated into another test tube. The acid layer is draped onto the drop plate and the reagent drop reagent was added. The result were obtained and recorded.
Next, my name is Noaim Fahim bin Aifin and I will present the result and analysis of high-performance liquid chromatography to determine vanillin in vanilla essential oil. Table 1 shows the linear regression equation and correlation coefficient R of the peak measurement for vanillin standard in HPLC technique and the absorbance in the ISO spectrophotometry. But in this study, we will only focus in HPLC technique. Linear relation were observed for vanillin standard between 0 and 4 ppm with correlation coefficient at 0.997 at HPLC. Next, table 2 shows the amount of percent weight over weight of vanillin for 12 samples determined by HPLC technique. The data show that for the 12 vanilla samples analyzed, the spectrometric assay consistently yield higher value than the HPLC technique. In HPLC technique, we can determine quantitative analysis by injecting the solution vanillin 60 micrometer per milliliter. In the results show the highest content of vanillin is 3.56%, while the lowest content in vanillin is 1.12%. Next, I will present about the conclusion of this case study. The pre-extraction treatment for pure vanilla slush about 2.5 cm resulted in higher vanillin content because there is direct contact perfectly between vanillin component in vanilla sample and extraction solvent. The vanillin content resulted from the solidation extraction is higher than the pre-collation extraction. This occurred because there is continually solvent purity process in solidation extraction. Therefore, the density of vanillin content in vanilla extract is high. So, we can conclude that using high-performance liquid chromatography is accurate. We will be able to identify vanillin in vanilla essential oil. The maximum concentration of vanillin is 3.56%, while the lowest concentration is 1.12%.